Hello, we are looking into the next section of Chapter 5, analyzing discrete random variables. So if you remember from Section 1, which hopefully you watched it earlier this week, we figured out or we learned about the difference between discrete variables and continuous. Remember, continuous is something that doesn't have any gaps. Discrete has gaps. So like discrete would be 0, 1, 2, 3, 4, 5, whereas continuous you can have, 1.2, 2, 2, 2. Some examples like discrete continuous, a perfect example of continuous is time, right? You can have like a half of a minute, you can have a quarter of an hour or a third of a second. Whereas discrete random variables or discrete variables, people is an example, right? You can't have a half of a person, or you can't have like 2.5 or 2.22 of a person, right? So discrete is where you have those gaps in between. So first thing you're going to do, we're going to look at displaying discrete probability distribution. So we'll be doing a lot of histograms with this. So notice here in this histogram that we have probability on the left side, the score is down below, and all you had to do was basically graph here each probability for each value, okay? You will have some assignments this week that does that, okay? Another thing we're going to be doing with these distributions is we're going to be describing the shape. So if you remember way back when we talked about the shapes of these distributions as symmetrical or skewed, I want you to tell me what is the shape of this distribution? Welcome back. Well, if you said the shape is skewed left, you are correct. Notice that the tail kind of goes off to the left, so that's why it would be skewed to the left and not skewed to the right. Okay, let's keep on going. So my example here, Pete's Jeep Tours offer a popular half-drive day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Pete charges $150 per passenger. Let's see the total amount of money that Pete collects on a randomly selected trip. The probability distribution of C is given in the table. Make a histogram of the probability distribution and describe its shape. Okay, so first thing you want to do when you're making these distributions or graphing them, the left here is going to be your probability. Down here will be your total collected. Okay, I'm going to go ahead and graph this and I'm going to pause the video here for a second. Okay, welcome back. Here is the histogram. Notice that we have our probability on the left. Our total money collected is down below. We've got each totals are 300, 450, 600, 750, and 900. And I'm just plotting how far up that probability would go. Okay. Now, this question is asking us to describe the shape. We don't have to find the mean or the standard deviation. They're not asking for measures of spread. They just want us to describe the shape. Now, it looks pretty symmetric. I would say roughly symmetric. I wouldn't say just symmetric because it's not perfectly. If you notice that, right, if you notice here that this bar doesn't come up or isn't as low as this bar here, the red one. So I would definitely say just roughly symmetric. So I would say that this distribution is roughly symmetric. Okay, so with mean, or the expected value of a discrete random variable, notice these two words mean the same thing, all right? So to find the value of, or the expected value of x, we're going to multiply each possible value by its probability, then add them together. A perfect example of this would be like your test grade, okay, or not test grade, if your overall grade. So like, you know how each grade is weighted or worth a certain amount. So like, let's say for homework, this is just randomly, let's say homework is worth 2% or 20%, sorry, not 2%, and you get 90. So you're going to multiply those two together. But then we also have like quiz scores, and quiz scores, let's say they're worth 30%, but you don't do so well, you only get 80% on those, or 80. Your grade for that is an 80. For tests, let's say tests is worth 0.35 and you get an 85. And then let's say we have participation, which is 0.05, but you get 100% on participation, okay? So just like how we would multiply to get a weighted grade, or even calculating semester grades for our school, so 45%, 45%, and then 0.1 is the exam grade. That's another way to calculate a weighted grade, or that's how you find the mean or expected value, okay? Let's do an example. So find the mean expected value. What's the average amount of money that Pete collects on his Jeep tours? So what I'm going to do is I'm just going to take each of the money collected and multiply it by our probability and then add them together. So 450 times 0.25 plus 600 times 0.35, and so on, all the way till 900 times 0.05. Okay, I'm just going to plug this in the calculator and get right back. Okay, I plugged that into Desmos here, and I see I got 562.5. So that would be our estimated mean, 562.5, or 50 cents, I should say. Okay, given the table, this table gives us the probability distribution for x. Once again, we're going to calculate and interpret the expected value of x. So when you have something that's got a lot more values, you could plug them all in at once, just like I did with the Jeep tours. Or there is an easier way to do this. And what you want to do is you want to go to this website here, and I'll even post this in this website in Google Classroom, and you want to go to discrete random variables, okay? And I'm going to plug in these values here. So I'm going to plug in, we're going to need a lot more here. I'm going to plug these in and I'll get right back to you. Okay, so I plugged those into, here are that app. Notice here's all my value, here's my probability, a decimal from 0 to 1, and all I'm going to just do is press begin analysis. And if you scroll down, they even plot the histogram for you, which is nice. And then they give you the mean, and then they give you the standard deviation. So the mean here is 8.12. So the mean, our expected value is 8.12. And that's all you'd have to do for that. Okay, let's keep going. Okay, the standard deviation of a discrete random variable measures how much the values of the variable typically differ from the mean. So to calculate this, again, I don't expect you to do this by hand. I wouldn't do it even by hand. I would use this website that I'm talking about here. Again, I'll post this website in Google Classroom. And all you'd have to do is put in the value, the probability, and the mean, and the standard deviation pops out just for you. Okay, thank you so much for joining me today.